All right, we have gone live, guys. Damn. I am going to change my category. Edit. It's science and technology, programming, software development, I guess. Educational. Cool. Okay, so hmm. Oh, this guy or girl is legendary, dude. I just saw them screencast their contest. That was crazy. I mean, like half an hour, three questions, and that half an hour was just like reading the question mostly, and then taking care of corner case. Like they immediately knew the answer. It's crazy. Okay, all right. So we're following a new format now. I'm not sure that's the spelling. I think it's this. Nope. Sorry. Uh, is this it? Awesome. Like, I guess. Okay, that's not him. My bad. Um, okay, let me just show you. Excuse my random. Should be this then. Although I think I tried this. Oh yeah, this is it. Okay. So basically, he sort of started doing the same thing that uh, I did. Um, and sort of after me, there was 11 days ago, and I think my first video was, of course, not as viewed as his, but my first video was 13 days ago. Hmm. All right. Um, Apart from that, apart from the fact that I got like 4 views in total on my videos. Anyway, um, cool. So we'll be putting up Ericto's stream on our channel while we're away, so that you can enjoy his content. He is, if you don't know, probably the best programmer in the world. Um, yep. So yeah, you should go ahead and follow him on YouTube as well as Twitch. Uh, Hopefully I can get a one-on-one with him someday in the future. All right, so let's begin. Here is my Google account. Awesome. All right. So till now, what we've been doing is we were solving easy problems, and then we started on medium problems, and then we started doing problems from um, companies, and more recently we started doing, I think, problems on problems from topics. Yeah, and by more recently, I mean myself individually. So what I did was, so I realized that I'm pretty bad at DP, and I knew I had to, find a way and get good at it. So I started doing it, doing easy DP problems to begin with, so that I can help sort of formulate some sort of logic in my head. Um, and then I tried some medium problems. But to be honest, I don't think I have the hang of it. It's still really, really hard for me for some reason, and I'm just not able to come up with solutions on my own. So after that, what I tried doing was I went to Ericto's YouTube channel, and there was 3 lectures on DP, which did help me honestly um, understand it a bit, in the sense that what you should take your parameters, and what your output value is going to correspond to, what type of deep should you be running, top down or bottom up, or should be iterative or recursive, what are the benefits, pros and cons, such and such. That did help a bit, but even after that, when I tried solving problems, yeah, nothing. Exactly. So I'm not sure how I'm gonna improve on this. I'm gonna keep practicing, of course. I think that's the only option really. Um, so I guess we can jump into some other category if you like. If you want me to solve problems that I can solve, sure, I can just pick up some easy problems. I mean, if that's what you want to see. But I think what would be rather fun instead is if we did relatively harder problems, um, or say popular problems, or yeah, something that you would want somebody's, how somebody thinks, and how what's the process of what somebody's thought process is while trying to solve something. Okay, that said, um, I went to top interview questions, and I noticed that I had solved most of them. So most of the easy ones, and mm, sort of quite a few medium ones as well, um, and not really any of the hard ones. So I don't think I solved this a good way, for sure. I don't know why it's even checked. I Oh, there is an answer. Oh, I think I did that myself then, probably. Oh yeah, this is my solution, sure. Oh, this returned which one is the minimum, and so this is just brute force uh, running through all the first items available on the list, and then just picking one. Uh, which is going to be number of list times length of one list, which is not great. A better solution that I did find, sort of, no, I think it was the same complexity, the other solution maybe. Uh, yeah, how can you sort list without reading it once at least? So basically take the minimum of these three and then select the minimum and then take the minimum of the next and so on and so forth. So that's reading one item. Not sure. I think that's NK only. But yeah, I think the best solution is probably priority queue, where you just push all the numbers in a priority queue and they just become sorted, and then you can just iterate through the queue and then you have your answer. Let me see what is the, yeah, runtime's pretty bad. This is faster than 5%, so it's pretty bad. So what is the complexity of this solution? So you go through all the lists once and you find the minimum each time. So you can go, say, the first k times and then go through one less number of lists k times, and so n lists k times, then n lists k times, and then sorry, n minus 1 lists k times. So that's n square k. This one actually. Um, and the priority queue would be uh, just nk. So, yeah. So anyway, so I guess this might be a good idea to begin with. So uh, we should at least know what the top interview questions are, right? So let's just start with that. So our objective until we're done with it is to complete all of these questions, even the hard ones. Yeah, I mean, even if you have to see the solution, that is. Okay, so let's say the stream setup fine. Uh, okay, so as usual, we will be starting with our notebook first and then write the code later on. Reverse string, not highly avoided, but okay. Write a function that reverses a string given input is a collection of characters. Do not allocate extra space. You must do this by modifying the input array in place with O1 extra memory. Please, you may assume all characters. I have no idea. Just literally, I mean, you could consider this to be a category of a problem. So it's basically a two pointer problem in a way, but even two pointer problems have conditions. This is just keeping two pointers toward at the end of the at both ends of the list and then swapping them and then moving both the pointers and then repeating it till we reach the center, like till low is less than high. So we can just code that out since that's literally nothing. Probably shouldn't take more than a minute or two. Um, Also, I noticed some I did watch some interview problems and some read some articles about how you should be, approaching your problem. So I mean, how you should be sort of writing the code down is, say when you have some small components in your code, always try to modularize and also de like delay them, like put them aside for later. For example, let me hide this weird smiley face. For example, now what we want to do is swap s um, low s high. So during an interview, just write this, and you can ask your interviewer later if you want them to write the actual code for the swap function or not. Uh, Depending on the complexity of that actual function, your interviewer would let you know if they actually want you to write it or not. So A is A plus B. Sorry, A is now A plus B. So B becomes A minus B, which is now A, and A becomes A minus B. I mean, this is totally up to you if you wanna write all this code or not. Uh, cannot find add. So definitely, so this run code button is the analogous of what you're going to be doing when you're giving the exam. So make sure that you uh, run through your code once when actually uh, in an interview. Really downward question. Never mind. I was just looking what it was. Fizz Buzz. Oh, this is the test question on HackerRank, maybe. Maybe. Okay. Downvoted. Let's ignore that. Move zeros. So, I mean, we said we're gonna do all of them, but if it's a downvoted question, there's no point because it's probably just an if-else question. Things we've talked about before. Okay, so given an array nums, write a function to move all zeros to the end while maintaining the relative order of the non-zero elements. Okay, let's bring out the notebook. So, oh, sorry. Let me move that as well. Yep, screw that. Okay, so yeah, so what I'm thinking for this question is, say this is your array, which is 0, 1, 0, 3, 12. So all you have to do is, so what we actually have to do is see how many zeros there are, right? Because they're the ones that are gonna go in the end, and everything else is gonna basically be swapped with your with the zero essentially. Um, so um, one way definitely is in the first pass you just count the number of zeros, and during the second pass what you can do is find the first non-zero number, keep a counter, say starting from I0, find the first non-zero number, say it's at 1, and then put it at I, and then I plus plus. So you'll be updating the array from left to right, and so now say I becomes 1, and then for our case, I is 1, um, and then obviously update this number to 0 as well, so that you don't, um, no, actually, never mind, sorry, what am I even saying? Yeah, that doesn't matter because you'll never revisit again. So update j to 3. So we'll update 1 here, this becomes 3, and then I becomes 2. This will become 12 later on when j is 4, and then the rest we'll update as 0. Yeah, sorry for a call. Yeah, so I was saying, yeah, and basically when you reach the place where, so maybe you reach the end, like j is at the end, j is equal to size of your array. At that point, from whatever is I till the end of the array, you update everything as 0. So that's 2 pass. You must do it in place without making copy. Minimize the total number of operations. Okay, so that's 2 pass. And one other way that I'm not sure would work or not is I'm thinking of something like swapping. Okay, so bear with me while I think. So basically, 2 pointers, one at the start and one next. So you find the first 0 and the first non-zero. You swap them. So you swap 1, 0. Then you find the next. So your 0 pointer is now here. So your non-zero pointer is here. So you find the next non-zero. Then you swap these. So come 3, so come 0. Then you move this pointer ahead. So from this point and from, yeah, okay, so from here you find the next non-zero and so on and so forth. So this will be your 0 pointer and this will be your non-zero. No, sorry. What will be your 0 pointer? This could have been numbers, so it's not going to be a non-zero pointer. Yeah, so you find the next 0 and the non-zero, and then you just keep swapping. I'm not sure if that would be better. Might be better in some cases. This might be better in some others. So let's just write this down and see what the runtime comes out to be. So let's hide that notebook. Okay. Um, oh, let's keep that notebook up and just keep the logic that was on. For, I mean, it's pretty simple actually. I don't really need to show that to you guys. So I'll just say what it is. So first pass is count zeros. So we have to keep 2 pointers anyway. So let's keep int um, nz equals 0, and okay, int start equals 0, and num equals 0 as well. So let's just write while true. So you don't know what the condition is right now. So while num equals 0, so we find the next non-zero number num plus plus and then put it at start. So num's start equals num, and then we move the start to the next position and num as well. You might want to look smarter by doing this. So we can keep doing that, and when we're done, our start's going to point at the first place that we need to start making our array as 0. So yeah, so the while condition I now remember is where while num is less than nums dot size, because after that this is gonna break anyway. Um, and I guess that condition as well. If num is greater than nums dot size, let's just break out of this while loop. I think we're gonna have to double break. Um, yeah, that's why most people don't use this while, because if they just use an if, it's easier to break out of this while loop. But that's fine. Um, so while start is less than nums dot length, uh, nums start plus plus equals 0, and it's in place, so we don't have to return anything. Sorry, nums dot size. Shut that down. Yep, seems to be working fine for the default case. I do expect it to run normally unless, yeah, this happens. So what was this? So what did we even do with 0? So we didn't even use it. Huh. Of course we don't need to. We just um so it's gonna be greater than equal to actually. Perfect. We used one variable, two variables. Yep, that's it. Okay. Next up is valid anagram. So given two strings s and t, write a function to check if they are valid anagrams. So if s dot size is not equal to t dot size, return false. That's just a base case. Uh, what if the input contained Unicode characters? So I've, I don't know if I've done this question before. I probably have because I know the answer to this question, or maybe I know the answer because I can think what the answer should be based on my experience. Um, so my real question is I don't know the bad answer to this question. So the bad answer would probably be to take all the characters in a list, create two lists for both the strings, and then sort them and then compare them. So that's n log n. But something much easier and cheaper is we create an unordered map and basically keep uh, like store true against all the characters of one string, and we iterate through the second string and see if the value for that exists in our map or is true, whatever. If it exists in our map, basically that means that and sorry, yeah, and is true means that ooh, sorry, not true, but we actually store the count of each character that we find against that character in the map, and then we decrease the count while iterating through our second string. And when we come to a situation where either it's either the character count is zero while looking it up, means that we don't have another copy in the original string. Hence, it's not an anagram. So I think it'll all make sense as soon as I write this down. So it's going to be a character to integer map. Now for I equals 0, I is less than s dot size, I plus plus. So again, I'm bad at writing iterators. I guess there's a better way to iterate through vectors, maybe, which gives you the item directly. We'll look it up afterwards. But for now, let's just do it this way. One sec. Mm, all right. So where was I? My bad. Yeah. So if m dot find st not equals m dot end, sorry, I m I plus plus, else m dot insert uh, pair si1, right? And then return true at the end if we never fail. So for int j equals 0, j is less than t dot size, j plus plus, if m dot find ti not equal to m dot end, which means basically found the item. Um, if m dot ti equals 0, return false, or else we would be doing mti minus minus, else return false. Basically, we didn't find it. also means that we failed. So if we ever hit a point, I was not declared, of course it was not. Let's just put it to J. It's the same number of times. So so if the count of each character is same, well and good. If not, you exit, and if you don't find the character at all, you exit again. So the it's probably maybe a bit slower because of the 16, 12, 8 thing that we see very often, or because we're accessing this element multiple times. You can just take it out once and then use it, but that's fine as well. Um, maybe. Okay, anyway, simple problem. If you have any idea about maps, sets, this extremely, should have been extremely simple for you. Okay, sorry. Contains duplicates. Given an array, find if the array contains any duplicates. Your function return true if any value appears at least twice in the array, and it should return false if any element is distinct. So the same, so it could be multiple elements occurring multiple times. Again, uh, when you talk about number of occurrences or uh, some sort of repetition or some sort of combination, maybe maps are your go-tos. So return true for unordered map bit to for int to int. I don't know, into anything, doesn't matter really. Or you can actually just keep a set, you know, and for int I equals 0, I is less than nums dot size I plus plus. So the thing about sets is that they only contain unique values. So if s dot has, I don't know, s dot find nums I not equal to s dot end, if you find it, return false. S dot insert nums I. In case insert. So I've never used sets before actually, so I'm not sure of the syntax. Okay. So sets C++ set un unique output false expected true. Sorry, my bad. So code's right, just the condition was wrong. So yeah, if it contains duplicates, then you return true, else you return false. All right, I do not think there is any other case to be handled where num size is bad or anything. So yeah, runtime is pretty bad for some reason. Might be slow. Ah, okay. Unordered. Let's try an unordered set and see if that does us any good. Yeah, that accepted work a lot better. Okay, maybe maps might also work better. Um, TLE, hash table accepted, sorting accepted. Awesome, cool. BRB. Yeah, sorry about that. So, okay, what I thought of a solution was to keep all the values in a map, and basically, if a value is repeated, then uh, the value against is the count against it is increased. And the first, we don't have to iterate through the map, but actually, we iterate through our array itself, and then check that if msi equals 1, then return I, right? So basically, the multiple copies will have I greater than 1, and the others would have, sorry, the multiple copies would have value greater than 1, and the others would have 1. And when you find the first value that is 1, that will be your answer. So this does seem to be running much slower than I had expected. I mean, it's faster than 26% of the results. So could be that the answer is easier than having a map, maybe? I mean, yeah. uh, hmm, okay. All right, other ways to solve it as well, in say one pass, but never mind. I think our answer was correct and expected, so that's okay. Calculate the sum, but you're not allowed to use plus and minus in that magic. So you have to find a plus b, given that you're not allowed to use plus. Okay, time to bring out our handy dandy notebook, I guess. So a plus b. How else do you do addition? So obviously it's super downvoted and it's bit manipulation, but we'll still take a look, because it's bit manipulation. We've not done a lot of those questions, just so that gives us maybe an idea about how to do those questions. Okay, so let's see bit uh, what options we have. So we have multiply and divide for sure. Um, but probably that's not going to work. We have right shift and left shift. What they do is divide the number by 2 or multiply the number by 2. Okay. not give and to uh, mask values sorry, check values, or give or to mask values. Sorry, that's single or. So let's just write the numbers in binary, I guess. 1, 1, and 1, 1. So that's 3 and 3. So let's say if we OR them with 1, sorry, if we do this and this with both the numbers, if they're both true, which means they're both 1. So this would be 0 and the carry would be 1. And if that with carry is also 1, then 1, 2, 3, this would be 1, and we have another carry is 1. And then if only carry is 1, then you have this is 1. So this becomes 4, 6. So yeah, we and basically check the last two bits and then right shift that shit and keep checking the last two bits. I guess that's what the solution would be, but it's probably somebody's mad. Okay. So yeah, I guess they're doing the same thing, is masking and then checking all those conditions, keeping the carry, and then uh, are they shifting A and B? A, they're not shifting A and B, they're just shifting the mask. Oh, this mask is not the sum. The sum is different. Okay, yeah, so I think it's what I explained itself. Plus, super downvoted, never gonna be asked. Let's move on. Intersection of two arrays, two. Sorry, did I? Yeah, let's hide that. Given two arrays, write a function to compute the intersection. 1, 2, 2, 1, 2, 2, 4, 9, 5, 4, 9. Ah, how about this? Ah, okay. So, yeah, basically by intersection they mean not a subset. not an exact match or anything. Just if yeah, it contains the elements that are in the other one or not. Okay, so this is a really neat trick that I learned from some time ago. That if you wanna say if you want the larger set as your first parameter and the smaller set is your second one, so you just check if your first set is less than your large than your second set, and you want it the other way around. So you just call the same function on itself, only in the case when nums1 is smaller, and that way nums1 will now be the bigger one without and we're not actually swapping values. So we don't have that swapping code basically. So what I'm thinking again is, I mean, I feel like all these easy questions are from maps itself. So what I'm thinking is make a map, store all the values with their count of from the larger set, and then all the values in the smaller set we check, and if the count is greater than 0, then we push it to our result. So we keep our result vector, and which is going to be the larger one always. Yeah, and then check each element if it exists in the map. If m dot find nums to j not equal to m dot end, so result dot pushback. I think they use the same logic because um, uh, because their answer was the same order of their smaller set. Yeah, probably. I mean, anyway, pushback nums to j and also m nums to j minus minus. Oh, also we need to check if the count is greater than 0. If m nums to j is greater than 0 and x tab and all right, and then we have to just return our result. Okay. IN before 100 typos. Perfect. Let's try adjusting this one. See what their code would have given. He would have given 1221 if it follows the same logic. Right. Alright. Let's submit this. Well, I'm sure we don't have to look at the answer, but I guess there's no need really. Yeah. Okay. Sorting is basically then iterating and finding the common ones. And if you don't find a common one, then just move on. Okay, missing number. The dedication coding on V-Day, they should just hire you for this. Yeah. I mean, I've been off for about 10 days. I was feeling actually pretty bad about not getting any responses from places that I had applied to. So got sort of sad. So I was really demotivated the past few days. But then I was like, that's not going to help me get hired. Might as well just study. Actually, I also got demotivated because I tried studying DP and I don't know why I couldn't get a hang of it. I'm gonna go through CL CSLR. What was that? CSLR? No, that's DSLR. Corman CR CLRS. Oh yeah, CLRS. So bad at coding, I don't even know CLRS. Yes, this is the book. I hope they have something in DP that I can help that can help me basically. Otherwise, I'm gonna watch some more lectures or something. Probably see Erecto solve some problems. Given an array containing d n distinct numbers, find the one missing from the array. Linear constant extra space. And this seems I might be stupid. 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for 0 to n, it's missing one number. So size is basically n minus 2, right? So what I'm thinking is to find the sum of all the numbers. And since we already know the formula for sum of all the numbers from 1 to n, we can just subtract and the difference would be our answer. So the size is 4 and our array is still, so the array is going to be till 3, right? 1, 2, 3, Ah, no, sorry, it's going to be plus one only. Hmm. Okay, anyway. So looking at some stupider test cases, like maybe 0 comma 1. So this is missing 2. So the answer should be again 2. Sum's gonna be 1. This is gonna be 2 times 3 by 2, which is 3. So yep, I mean the only case would be 0, I think, which might be worse. Okay. Yeah, so 80%, I think that's as good as we could get. Merge sorted arrays and palindrome linked list. Okay. I think someone's actually asked me this before. Okay. Highly downvoted question.